Hello students, I welcome you all to the second video on chapter 12 surface area and volume. In a previous video we had solved NCERT exercise 12.1. Now in this video we are going to solve exercise 12.2. In this video we have to solve questions on volumes of the solids. So first question is a solid is in the shape of cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So this is the diagram. The cone is situated on the hemisphere. They are sharing same circular base. So radius is equal to 1 centimeter. And also it is given that the height of a cone is equal to its radius. So height of a cone is 1 centimeter, radius is 1 centimeter. We have to find volume of the solid. So the idea behind such type of question is very simple. You are going to find volume of this cone and you are going to find volume of this hemisphere and then simply add them in the end. So volume of cone, this is the formula 1 by 3 pi r square h. Now they have said that keep the answer in pi. So we are not going to substitute the value of pi. So pi by 3 is the volume of cone. Volume of hemisphere is 2 upon 3 pi r cube. Replace the value r is equal to 1. You are getting the volume of hemisphere is 2 pi by 3 centimeter cube. So total volume of the solid is equal to the addition of the volumes of the individual solids. One is cone and another is hemisphere. Add them, take LCM, you're going to get pi centimeter cube. Simple. Question number 2. So Rachel is an engineering student, was asked to make a model shaped like a cylinder with 2 cones attached at the end. Now using thin aluminum sheet at the end by using thin, okay. The diameter of the model is 3 centimeter and its length is 12 centimeter. So total length is 12 centimeter and the diameter of cylinder and cone is 3 centimeter. 3 centimeter is diameter. If each cone has height 2 centimeter, find the volume of air contained in the model. Okay, so the length of the model is 12 and the length of cone is 2. This is also 2. So the length of cylinder is 12 minus 2 and 1 more minus 2. Okay, 8. So let's begin the solution. So we have to find how much air this model can contain. So simply we have to find volume of cone. Then there is similar identical cone in the bottom. Just multiply it by 2 and add volume of cylinder. That's the idea behind getting the volume of this solid. These are the given things: height of cone, diameter, total height of the model. Volume of air, we have to find the volume of air in the model. So volume of cone, I have given V1, the short name for the volume of cone. So this is the volume of cone, 1 by 3 pi r square h. So what is the radius? Radius is 3 by 2 because diameter is 3. So I have written directly radius is equal to 3 by 2. Simplify this, cancel whichever the numbers are getting cancelled, and I have 33 upon 7 volume of one cone. Now height of cylinder is 8. So 12 is the total height minus height of one cone and height of another cone. So volume of cylinder, the name is V2. Volume of cylinder is pi r square h. Substitute the value, cancel the numbers and keep it in fraction. Now volume of air in the model is V1 plus V1. So what is V1 plus V1? Volume of cone taken twice. Okay. So you can write it like this also, 2 times V1. Now take the LCM. It's very simple to take the LCM because denominators are same. And in the end, divide it, you will get 66 centimeter cube. I hope this example is clear. Let's proceed. Third question. A gulab jamun contains sugar syrup up to 30% of its volume. So one gulab jamun contains 30% of its volume as a sugar syrup. So find approximately how much syrup would be found in 45 gulab jamun. If each shaped is like cylinder and two hemispherical ends with length 5 centimeter and diameter 2.8. So this is the shape of one gulab jamun. So what I am thinking is we will find volume of one gulab jamun, then of that volume 30% is sugar, then we will multiply that sugar amount with 45. Okay. So let's read the given thing. Length of gulab jamun is 5 centimeter, diameter is 2.8 and total number of gulab jamun is 45. The total length is 5 centimeter, diameter is 2.8. So radius is 2.8 divided by 2. So that comes 1.4. Now for hemisphere, the radius itself is a height. So we have to subtract 1.4 from 5 to get only the length of cylindrical part of the gulab jamun. Okay. To find amount of sugar in 45 gulab jamun. So base diameter is 2.8, radius is this, height of cylindrical part. Height of cylindrical part 5 minus 1.4 and one more 1.4. So it comes 2.2. Volume of hemispherical part. So the nickname is Vs, okay? And we have to multiply it by 2 also. So 2 by 3 pi r cube. Put the values of radius, and we know that 1.4 is divisible by 7. So pi I have substituted 22 by 7. So volume of sphere comes 5.749. So it will take time to multiply the things and you will get 5.749. So try to do this multiplication part very fast, okay? Now the volume of cylinder. Volume of cylinder is pi r square h. Pi is 22 by 7. Radius is 1.4 square 2.2. So elaborate it, 22 by 7, 1.4 2 times and into 2.2. Cancel this, you will get 0.2 and multiply all these numbers smartly and quickly. You will get this. 13.552 centimeter cube. So the volume of one gulab jamun is volume of hemisphere plus one more hemisphere, okay, plus volume of cylinder. So this is what I have done 2 times, okay. Multiply them, add them. So volume of one gulab jamun is 25.05. Now one gulab jamun contains 30% of sugar syrup. Amount of sugar syrup in one gulab jamun is 30% of volume, 30 upon 100. So this much volume is sugar syrup, okay. This is the volume for one gulab jamun, okay. So multiply it by 45. So total volume of sugar syrup in 45 gulab jamun is 45 into 7.515. So multiply it, you will get the answer 33 338.175 centimeter cube. Remember that I have already done these calculations before making this video. So obviously you are going to waste, or you have to invest time in doing this calculations. Okay, so next question is, a pen stand made up of wood is in the shape of cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 15 centimeter by 10 centimeter and 3.5 centimeter. The radius of each depression is 0.5 centimeter. So this radius is 0.5. So from here till here, this is 0.5. And the depth here is the height of conical depressions, is 1.4 centimeter, which is divisible by 7. Find the volume of wood remaining in the entire stand. So these 4 holes, they are from these holes, volume is gone. Okay, so the wood is left in this part. So we have to find how much wood is present in the wood stand. So the idea behind this is, we will find the volume of cuboid minus what? Volume of 4 cones. So 4 into volume of cone. Okay, this is the idea behind this question. So this is the diagram. So dimension of cuboid is length is 15, breadth is this, and height is this. Depth of cone, that is my height, and radius is 0.5. Okay. We have to find the total volume of wood in stand, that is volume of cuboid minus 4 times volume of cone. I hope this is clear. So let's find the volume of cuboid. It's very simple, length into breadth into height. Let's put the values, multiply it, you will get 525 centimeter cube. Volume of one conical depression is 1 by 3 pi r square h. So 1 by 3 instead of pi, it is 22 by 7, 0.5, 0.5, that's the radius, and height 1.4. 7 cancels this, then you have to multiply this and try to get this value, or you can simplify this further. Okay, so I think this will be 11 upon 30 also. This also works. Okay, now I have to this is the volume of one cone. We have to multiply this by 4. Why? Because there are 4 conical depressions. So multiply this by 4, you will get 22 by 15. That is approximately 1.476. So you have to get this value by dividing this. Okay. So do your own calculations to get these values. So let's stick to the idea, total volume of cuboid minus volume of 4 conical depressions. This is the answer. Next question. A vessel is in the form of inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeters. So radius is 5 centimeter, height is 8. It is filled with water up to the brim when lead shots. So these ball of made up of lead, each of which is a sphere of radius 0.5 centimeter, they are dropped into the vessel. So obviously water will fell out. Okay. So how much water is fell out? 1/4 of water flows out. Okay, how many lead shots? We don't know. So we know that 1/4 of the total volume of the cone falls out. Find the number of lead shots. This is the diagram. So this is the lead shot in spherical shape. The radius is 0.5 centimeter, and how many we don't know. This is the shape, conical vessel full of water. Okay, so this is the given. Base radius of cone is this, height of cone is this, radius of lead shot. We have to find the number of lead shot dropped into the vessel. Let the number of lead shots dropped be n. Okay, I have assumed the number of lead shots is n. So these leads are n in numbers. Okay, n in numbers. So we will find how much, what is the volume of one lead shot and what is the volume of this cone. Okay. Now, if volume of one lead shot into n, that much water is spilled out of this conical vessel. So this is the idea behind comparing the two things. We have to compare the volume of n lead shots equal to the what volume of water fell outside. So what I have written is volume of water is equal to volume of conical vessel. That's clear. So I have done the calculation to get the volume of water, because it's given that 1/4 of, okay, 1/4 of water flows out. Okay, so I have got total volume of water inside the conical vessel in terms of pi. Okay, volume of one lead shot, 4/3 pi r cube. Put the value of r, do the calculations, keep the answer in pi. This is the volume of one cone. This is the volume of one cone. How many, sorry, volume of one lead shot. So what is the value of n lead shot? Just multiply it by n. So you will get n pi by 6. This is the total volume of n lead shots, and these many lead shots are dropped into the conical vessels. So obviously these objects will displace some water outside equal to their volume. So it is given that n lead shots dropped, then 1/4 of vessel volume flows out, which implies volume of n lead shot is equal to water displaced. So how much water is displaced? 1/4 of total volume. By how many leads? N lead shots. So these two things must be equal. Okay, so n pi upon 6 is equal to 1/4, 1/4 of 200 pi upon 3. So that's why I have kept pi. Okay, no need to put the value of pi, because in comparing two things, they are going to cancel. Now simplify this further, you will get n is equal to 100. I hope this is clear. So there were 100 lead shots dropped into the conical vessel. Let's take next question. Solid iron pole consists of a cylinder of height 220 centimeter and base diameter is 24 centimeter. So radius is 12. Height is, a solid iron pole consists of cylinder of height 220. Okay. Which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. We have to find the mass of the pole. Given that 1 centimeter cube has approximately 8 grams of mass. This is density. Okay, this is density rho. 8 grams per 8 grams per centimeter cube. So density. We have to find mass. So we know what's the relation between density, mass and volume. So we have to use this over here. Okay, so in given, what I have written is height of bigger cylinder is this, height of bigger cylinder, sorry, diameter of bigger cylinder is 24, height of smaller cylinder is 60, radius of smaller is 8, density is this. Mass of whole, we have to find mass of whole pole, this structure, this whole structure. So radius of bigger cylinder is 12. Everything I have written in detailed manner in this question. Volume of cylinder is pi r square h. Volume of bigger cylinder V1. So the nickname I have given is V1. V1 is volume of bigger cylinder. So pi r square h. Do the calculations. Keep the answer in pi. Volume of smaller pole V2 pi r square h. Do the calculation. 3840 pi centimeter cube. So total volume V1 plus V2. Okay, so this is the volume, total volume. Just add them, keep the answer in pi. Then we know that mass is equal to volume into density, or density is mass per volume. Okay. So mass of pole is volume into density. So the answer is going to come in grams. This is in grams. How to convert grams to kg? Just divided by, just divided by 1000. So 1000 will divided by 1000. So 1, 2, 3. Okay. So this is the answer. 892.26 kg is the weight of the pole. 7th question. A solid consists of right circular cone of height 120 centimeter and radius 60 centimeter. Standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom, and find the volume of water left in the cylinder if the radius of the cylinder is 60. Okay, so just look at the diagram. What is given in the question is the radius of this solid is 60, and the radius of this cylindrical drum, or whatever it is, vessel, yes, right circular cylinder. Okay. The radius is same. So if we insert this inside this cylindrical vessel, the circumference is going to touch each other's circumference. Okay. Now what about height? What about height? The right circular cone is 120 centimeters. 120 centimeters is the height of this cone, and 60, which is the radius of hemispherical part, is the height of this hemispherical part. So 120 plus 60 is 180. Okay. What is the height of that cylindrical vessel? Height is 180. So this solid is exactly going to fit inside this vessel. The top and bottom is touching. The what we call this, the circumference is also touching each other's boundary. Okay. So what we have to find, this cylindrical container is full of water. When we put this thing inside it, the water will get displaced, it will come out. How much water is, find the volume of water left in. Okay, we have to find how much water is left inside the cylinder. How can we do this? Total volume of cylinder, this total volume of cylinder minus volume of this solid will give you the amount of water left in the container, cylindrical container. Okay. Given thing, height of cone, radius of cone and hemisphere, height of cylinder, radius of cylinder. we have to find volume of water left in the cylinder. Volume of cylinder Vc pi. So what I'm doing here is I'm finding the volume of cylinder. Vc is equal to pi r square h. Put the values. Keep the answer in pi. If required, we will replace the pi in the end. Let's not worry about this pi. So do the multiplication. You will get 6,48,000 pi centimeter cube is the volume of cylinder. Volume of cone. Volume of cone is 1 by 3 pi r square h. So 1 by 3 pi as it is. Then this 3 will cancel either 60 or 120, any one of it, and multiply it to get 1,44,000 pi centimeter cube. So volume of hemisphere is this. So what I am doing is I have found volume of cylinder, volume of cone, and volume of hemisphere. These two shapes are forming that solid in the question. So I have to add it. I have to add these two things. They both are same. Okay. So volume of solid is volume of cone plus volume of hemisphere. Add them, you will get this. If the solid is immersed inside the cylinder, then volume of water displaced is equal to volume of solid. This much water is gone. Okay, this much water flows out. So water remaining in the cylinder is volume of cylinder minus volume of solid. This S is solid. Okay. Subtract it, you will get this answer. Now this answer is in centimeter cube. So what conversion I have done? I have converted it into meter cube. Okay. So 1 centimeter cube is 0.000001 meter cube. Excuse me. Water remaining in cylinder is, just multiply it, and everything converts into meter cube. This much water is left. Sorry. I think this is the last question. Okay. This thing I had planned to give you as DIY, do it yourself. But still I have done a little bit calculations. A spherical glass vessel has cylindrical neck, 8 centimeter long. The height is 8 centimeter. 2 centimeter is diameter. So 1 centimeter is the radius. And the diameter of spherical part is 8.5. So the diameter from here till here is 8.5 centimeter. By measuring the amount of water it holds, a child find its volume to be 345 centimeter cube. Check whether he or she is correct. Okay, taking the above as the inside measurement, and pi is this. So what we have to do, the answer is already calculated by some student. We have to check whether he or she had done the correct calculation or not. How to get the volume of this such type of solid? We will find the volume of the cylindrical part, we will find the volume of the spherical part, add them. So 8 pi is the volume of cylindrical neck. This much is the volume of spherical part. Add them, put the value of, so this is the addition, this is the value after adding it, put the value of pi, and multiply it. So 346, answer is 346.46. This is the answer, and the answer which was given by the student is 345, which is not equal. That's a big difference of 1.46. Okay, so the child is not correct. I hope this exercise is clear to everyone. If there is any doubt, please feel free to ask in comments. So that's all from my side in this video. Thank you everyone.